Hi, everyone. I just wanted to make this kind of short supplementary video to clarify some things about functions because I feel like generally the experience that people have earlier on in their math education and what a lot of people might be coming into this class with is very confusing on this topic, and it's never really addressed specifically, and people are not taught to think carefully about this, okay? But for this class, it's extremely important to be at least be aware of the correct way to think about functions, okay? Because there's some subtleties that will confuse you if you're not aware of what's going on, and you'll be banging your head against a wall trying to figure out what's going on in some problem. And if you internalize what I say here, you'll avoid that, okay? So the first thing I want to say is let's talk about the notation a little bit. So if you wanted to be really careful all the time, or just in general, if you just want to be really careful about functions, there's a distinction, okay, between writing f and writing f of x, okay? F is a function. F of x is a number. Okay, I know you might be thinking, well, x is a variable, so f of x is a function because x can change or something, okay? But I would just say just for now, try to think about basically just think about this as a number. You know, even if x kind of changes value in some sense, for any given value of x, f of x is a number, right? So just remember that. If you really just want to think about the function in its entirety, try to get in the habit of thinking about just the symbol f, okay? It seems like a strange distinction to make, but it's really, really important to be aware of this because it has some implications I'll show you, all right? So like, for example, okay, yeah, we can just get into this right now. So f is a function, f of x is a value. If we're being careful, okay? So what this means is, like, if you write something down like this, oops, sorry. Dang it. Something like that, right? If I write something like that, uh, devoid of context, it might not be obvious whether I'm saying f of x plus g of x as functions always equals 3, like it's the constant function 3, right? If I'm adding these two functions together completely at every value of x and I get 3 always, right? Or maybe this equation is just true for a specific value of x, right? And like usually that would be clear from context. Like we would talk about what x is really. We would actually define it and say like, okay, let x be any real number, okay? And then I make this statement, well, then that means it's true for all of those values of x, right? Or I would say, let x be this specific number. Maybe x is the solution to this equation or something like that, right? So sometimes these statements are true for specific values of x, or sometimes they're true for all values of x. And so keeping the distinction between f being the function and f of x being a number will help you avoid those confusions, I guess, all right? So the other way of writing this would be to say something like versus f plus g equals 3. This equation would be kind of an elliptical way of writing or asserting that when you add the functions f and g together at all of the points in their domains, right, then you get a new function which is the constant function 3, right? It's the function which always outputs 3. So here actually in this equation 3, this symbol 3 actually represents something not quite just the number 3. It's really the function which always outputs the number 3 at every input, right? So this is a, equation of functions. This is an equation of values. Okay, so there's a distinction here. So that's the first thing that I wanted to talk about. Now, well, let me just use the eraser for a second. So there's got to be a better way of doing this. I'll figure it out eventually. So the other thing that I want to talk about has to do with what defines a function, like the data, right? What are the data that constitute a function? So what is a function? A function consists of three things: a domain, which is a set, a codomain, not range, slightly different, and an assignment of values. So one value from the codomain for each, dang it, value in the domain, right? So the domain is the entirety, right? Okay, so it's like you've probably been used to thinking about functions like something like f of x equals 1 over x or something, right? And so when you just write that down without any further explanation, it's implicit that the domain of that function is all of the real numbers except for the ones where that expression doesn't make sense, right? So actually, technically, the domain of that function is the real numbers minus 0 without the point 0, basically, right? That would be the domain. A function must, by definition, be defined at every point in its domain, okay? So yeah, and that convention will stay true. So if I write down a function, if I write down something like f of x equals 1 over x, right, without any other explanation, by default, the domain will always be just all of the numbers where the expression actually makes sense, okay? But that doesn't have to be the domain. I can specify other domains, right? And I can specify whatever codomain I want as long as all the values that the function takes on actually are in the codomain, okay? But so there's a lot more possibilities here with these three things than just like writing down rules like f of x. So importantly, sorry, let me write this. So a function is not a rule philosophically for our purposes. So some people actually debate whether a function should be one thing or the other. For our purposes in analysis, a function is not a rule. It's an assignment of values, which could be anything. So what that means is like you could actually, if you had the power to generate an infinite number of random numbers, you could build a function by just generating infinitely many random numbers and just assigning each random number that you get to one of the input values for the function. And you'd get a function that way. It would be completely insane. There's no way to write functions like that down uniquely, right? But you can kind of imagine what they vaguely look like, right? Those functions we consider to be perfectly valid. I mean, they exist. Even though we can't really describe them specifically, we can't really write them down, they still exist, okay? So we have to account for the possibility when we talk about functions. If we say something like let f be a function, that's technically a possibility, right? And another subtlety about this that I want to make clear is that the domain and the codomain are just as much a part of the identity of the function as the actual assignment of values, right? So if I write something like, so f from R to R, by f of x equals x squared, let's say. Okay, so that's a very simple function. I'm able to define it with a very simple rule, right? This is, you know, for all x. G from 0 to 1, this is the interval between 0 and 1. So this is just the set of numbers between 0 and 1, including 0 and 1. Okay, well, that's just some notation that you'll have to get used to. But yeah, this is just the interval. It's like a little segment of numbers, right? So that's my domain. Oops. Right. And then h from 0, 1 to 0, 1. H of x equals x squared for all x. Are technically distinct. Okay, so technically speaking, like very technically speaking, these three functions are all totally different from each other, okay? It's true, you can say things about them, like you could say that at any point where all three of the functions are defined, they have the same value. You could say that, for instance, right? But you can't just say f equals g or g equals h. They're not the same object. They have different, slightly different data, right? And the reason that this is important is because it's really common for people to think that, like, if you have a function that's defined on some kind of restricted domain, like an interval, like g or h, right? Those are defined on intervals. Let's say, and then like people try to think about like, okay, what if I come up with a rule that gives the values of those functions? Then I can just like extend that to other points. So like the function has values outside of its domain, right? Like you think about the function g of x equals x squared, and you automatically think like, oh yeah, that has values for all values of x, right? But it's confused. That's just like, that's a not quite the right way to understand it, because technically with the function g, if I just hand you the function g, you can't know what the values of g are outside the interval of 0, 1. They don't exist. G does not have values outside the interval 0, 1. Same thing with h. They just don't, okay? Even though g looks like x squared, right? It looks like a piece of the function x squared. The function g does not have other values outside the interval 0, 1, okay? So I just want to make that absolutely clear. This is really important. And I hope you take this seriously and try to internalize it, because it'll help you a lot. Thank you.